listen to me.
Goodness, here's so much game plan. So much going on. No, this is all like during study hall one day. And,
What are you talking about?
sure, like there's so much going on in like her planner. It's like, who did that? Like Lord.
Yep.
It's like snowflakes going down the page. It's weird.
Busy still writing it?
Like, I have like drawings in some pages, but they're pages that I don't need.
Sorry, I was gonna try to grade your quizzes really fast.
Okay with that.
I always procrastinate, so
I think-
it'd be in
Do you think just this much would be enough for like the writing? Well, that starts here.
It's like, it's not a sentence. That's good, so this is what you're gonna like make.
Well, yeah, I've already made it, but I made room 101. I just need to make, like, I'm making like clay people and clay beds, and I need to make like the actual jail lines, but I made room 101 already.
So you're basically done. That's not gonna take you.
It's still probably gonna take me a while.
Right.
Because I'm debating whether I'm actually gonna paint the clay people. I probably won't, because that'll take. But the thing is, I think the only clay we might have is like blue and maybe yellow. But it doesn't matter. I mean, I put a lot of work into it.
If it is more season. Alright, looks like you did a nice
I don't have
job.
left. Because I was gonna like go to my computer and just say like Lego people, and I was just like, oh, I'll just make clay people. Because I mean, I'm only gonna have like Julia in one cell, and then like Winston in room 101 with like the rats. But
Is the camera on?
mm-hmm.
Lauren, don't copy this. This isn't for your class. Well, she didn't start.
Yeah, and that's from simplifying. I really like that.
Okay, I think mainly number 3, right? Because you guys both missed number 3.
Yeah, I got -1 on number 3 and -2 on number 5.
It was
number 4.
3 points each, so is that a 45? Number 3. I'll do it on.
Oh, I didn't switch the sine to cosine. I'm stupid.
Alright, I'll do it on here since you have the camera.
Oh, okay.
Number 3, I think everybody got to maybe, well, when you take the derivative, you have sine x times secant x tangent x plus secant x cosine x, right? And then you would want to change all of these to be like a version of sine and cosine. So this would be sine x over 1 over cosine x. You could actually leave that as tangent x plus 1 over cosine x times cosine x. Follow? Yes. Only reason why I'm doing it all is because you both did part of this. One of you did part of the simplifying, one of you did the other part of the simplifying, I think.
I messed up number 4.
Number 4?
I circled it.
What about number? Oh, number 4, you just
Took it.
didn't follow the rules of math. And you tried to simplify it more than you thought you did.
Okay.
Okay, so then the cosines would cross out here, so that would just be 1. Right? And then this would end up to be sine over cosine, which is tangent. So then you have tangent squared x plus 1. Are you guys with me? I don't remember what you guys, one of you had this, I think. You did? What did you have, Skylar?
I just left it as sin x, secant x, tangent x plus 1.
Okay, yeah, so you simplified this part, but not this part. And then this is one of the trig identities also, which is secant squared.
Oh, so we should count.
Yeah, I didn't count off for number 4. I just said, this is the,
Okay.
so don't do this.
Okay.
Because you had the right answer.
Sort of thing.
Okay, and then what, Skylar, yours was 5?
Yeah.
Yeah, I think you may have written the problem down wrong, honestly. Because if you had a 2 at the beginning, and there wasn't a 2 in it, number 5, it was cosine x over 1 plus sine x. Is that what the
I think
problem
I'm just
is?
really dyslexic.
Because the one before that had a 2
Oh, you put
in
number
it,
4 at the bottom.
so...
Yeah. I put number, yeah.
So...
I put number 4 as bottom of number 5.
Sorry about that.
So is that why?
I mean...
Is that the only part that was wrong? Was that should have been a 1?
The answer is there was simplifying for that one too, so I'm not sure if you would have been able to simplify it if you didn't have it written down right. But ultimately this was the answer.
Oh. And this one I'm just retarded. Okay. I do so much better on homework than I do on these tests.
You didn't do bad on the test.
I make stupid, like, it's not that I don't know how to do it, I make stupid, like, errors.
We all do. Was there any other questions that you guys had? No, I was happy with it. So go ahead and get out your notes. We're gonna do. What happened?
Settings. Lauren changed it.
We're going to do what is called implicit differentiation.
Oh,
Speaking
I was
weird.
gonna ask, how, like, is our final gonna be, like, over everything that we've learned so far?
No. Well, it's gonna be on derivatives. Everything that we've done with derivatives.
So, like, we're not gonna have to, like, graph this sine and cosine thing, or yes?
No, that was mainly to,
We have to do
Praise the
limits,
Lord.
because I
No.
don't like those.
no. It's gonna be
I don't
over,
remember how to do it.
it's gonna be over derivatives. So, and we've kept those throughout, you know, like starting with when we first did derivatives, but we've had to keep doing them throughout, so it shouldn't be too much of a. Okay, so implicit differentiation,
It's still black.
you can't
Yeah.
see it.
It's still at settings.
Why is it doing that? Can you see it now?
Yes.
Oh, okay, good. It allows us to find derivatives of the functions that are not defined or written explicitly as a function of a single variable. So right now, everything we've had has been like y equals this, f of x equals this. But that's not going to be the case anymore. I think it's really fun. I don't know if you guys will like it or not, but. just gonna do a lot of examples, so you know what I mean. Right now, you probably
Just like
don't really.
substitute the y and the x and x is a
Yeah. You got
Sounds
this,
like there's a lot of
Olivia?
steps.
Yeah. Okay. So to find the derivative, we're gonna differentiate both sides with respect to x. We treat y as a differentiable function, which just means that we know that it has a derivative, and we apply the chain rule. So it's kind of like having like sine x as a function, and so we would take the derivative of the sine x and then multiply it by whatever the x was. Say it was like 3x to the fifth when we did the chain rule. You know what I'm saying? But in this case, we're gonna have just the y, and then the derivative of the y will be the y prime, or the symbol for derivative. And then we'll solve for the y prime. And we'll talk about the second derivative in a minute. But so we'll do plenty of examples hopefully, and you'll get what I'm saying. First one, we'll have y squared equals x. So if we're trying to find the derivative of y, we need to take the derivative of both sides. So we take the derivative of y squared would be what? 2y. But we're differentiating this with respect to x, so y is just like some unknown function that we don't know what it is. So we have to multiply that by y prime. Sort of, that's where the chain rule part comes in. So we take the derivative of the y squared, but then we multiply it by the derivative of y, which is what we don't know. Okay? And then we take the derivative of the x, which is what? 1. And then we solve that for y prime. So how would we solve that for y prime? Divide by 2y. So that gives you your answer. Y prime equals 1 over 2y. Okay, questions about that? Alright, 3x squared equals 5y squared plus 1. So we take the derivative of both sides, so what's the derivative of 3x squared? 6x equals, and then the derivative of 5y squared would be 10y, and then we have to multiply that by y prime. And the derivative of 1 would just be 0, so we don't need to put anything for that. And then we solve that for y prime. And how do we do that? Divide by 10y. Good. So y prime will equal 6x over 10y, or that would reduce to what? 3x over 5y. How do you feel about that? Yes? You guys both seem really tired today. We need to get some energy. I'm with you too. Alright. 4x squared plus 2xy squared equals 4. So when we have the x's and the y's combined together, we're going to have to use the product rule. Because it's like, just like when we had like tangent times secant, they're two different functions, so we have to multiply the derivative of one times the derivative of the other. But first, what's the derivative of 4x squared?
8x.
What? 8x, good. Okay, and then we'll have 2 times the derivative of this, basically. Let's group this kind of. So I have to use the product rule on that part, the xy squared. So we have to do first times the derivative of the second plus second times the derivative of the first. So x is the first times the derivative of the second would be what?
2y.
2y times y prime. And then plus second would be y squared times the derivative of the first, which would be,
Yeah, why do we find the derivative of both of them? Never mind.
we're using the product rule,
Okay.
right?
Mm-hmm.
Okay. What's the derivative of the first? 1. So just, you can put it or you don't have to. Equals 0. Okay, good. So we'll have 8x plus, and then we'll distribute the 2 to both of those things. So it would be 4xy y prime plus 2y squared. You with me on that?
Oh, that's all in
And then we have to solve that for y prime. So we'll leave the y prime, that term that has the y prime in it, on one side and move the other stuff over to the other side. So minus 8x and minus 2y squared. So 4x y prime equals negative 8x minus 2y squared. And then what would we do? That off. Divide by 4xy, yes. So you have y prime equals, and we can divide a 2 out of all of that stuff, so it'd be negative 4x minus y squared over 2xy. Isn't this fun?
Olivia's like, sure.
I like the first two.
Yeah, they get more complicated. Do you have any questions about that? No? Okay. Let's do. Alright, 2x equals 5y cubed plus 2y. Okay, so tell me what we'll do. Or what we'll have. Skylar, say it out loud for everyone to hear.
2 equals 15y cubed plus,
Why, what?
or squared. I said cubed, I meant squared. I wrote squared. Plus
Y prime.
y prime plus 2.
Plus 2 times
I
y prime.
Y is 2 times 5 times twice.
Anytime that you have a y, you take, in your term, you take the derivative of the term with the y in it, and then you have to multiply it by the y prime.
How come we didn't do that in the last
For which one?
problem? We just did y prime once.
Because we were, on this, we were using the product rule. So we only found the derivative of the y, and there's really only one y. So when we were doing this, we weren't finding the derivative of the y at that point. It was when we were saying second times the derivative of the first.
Okay.
Does that make sense? But here there's more than one term that has a y in it. They're separate terms. Okay, so again, we have to solve for y prime. How are we going to do that in this type of problem? Let me help you. You're gonna have to factor it out. You have to factor out the y prime out of both of these terms. Make sure they're all on one side of the equation, which they are. But then you can factor it out, so then you have y prime times 15y squared plus 2. And then we can divide by what?
15y squared.
Right. So that's your answer. Y prime equals 2 divided by the 15y squared plus 2. Do you guys think you could do these on your own? Yes?
I hope so.
Okay. Just trying to figure you out. I'm so quiet. Alright,
Like
5y equals 3x squared minus x cubed y squared. So who wants to tell me? Olivia?
5y prime equals 6x minus 3x squared y squared plus 2y y prime 3x. No, x cubed.
Man, I made a
3x? X cubed.
Good. And if you did, I usually do first times the derivative of the second, but that's fine. She switched the order of that. But what are you looking at, Skylar?
That's probably why.
Did you put this first? Like 2y. Well, you probably have like x cubed. That's how I would have said it. X cubed
was the
times-
first times the derivative of the thing.
Well, with the product rule, it doesn't matter because you're adding them. So you might have a combination of this, but it, she just did it so confusing.
Okay.
Yeah.
So if I were saying it out loud, I would probably say x cubed times 2y times y prime plus 3 plus y squared times 3x squared. That's probably what I would say. Is that what you have on your paper? Yes? No?
Well, I ruined the laws of math and didn't do the product rules.
Oh, okay.
But it,
Don't do that.
Yeah. So apparently I can't do this by myself.
Well, we'll keep practicing. Okay, so, but just make sure the minus, or like if you ever have a constant term in front of that, you would make sure you multiply that by everything when you're done. Does that make sense? So in this case, it was a minus. So we have 6x minus 3x squared y squared minus 2, let's say, x cubed y prime. So then we need to make sure all the y primes are on one side together, right? Actually they're not, so we need to add this one over to the other side.
Why wouldn't you divide it out?
We will eventually, but we need to get them to one side first. So we'll have 5y prime plus 2x cubed y prime equals 6x minus 3x squared y squared. Then what do you think we'll do?
Factor.
Good. Factor out a y prime, so y prime times 5 plus 2x cubed y.
Then divide.
Good, then divide. So y prime equals 6x minus 3x squared y squared divided by 5 plus 2x cubed y. Okay, let's do one more. And we'll save the second derivative for another day.
Sounds good.
So this one's gonna be really fun. Okay, what do you have? What would you have?
10x.
10x equals
2, 3y cubed plus 3
Oh, you have to do the chain rule.
times 9y squared. Y prime.
very good.
Oh, sleep like that.
So really all of this side is kind of multiplying if you leave the 3y cubed plus 3 as a factor. So we could just divide by all of this, 2 times 3y cubed plus 3 times 9y squared.